Okay, today we're going to look at Chapter 11, Radicals. We're going to start with Section 11.1, Simplify Radicals. So radicals really are square roots. So a principal square root is, if we have a, it's a positive real number, then the principal square root of that number a is defined by, and then we say, okay, we have the square root of a is equal to b if and only if a is equal to b squared. So what happens is we take the square root of both sides, and the square root of b squared is b, and then that's what the square root of a is equal to. Now, in the square root of a, the sign is called the radical symbol, and a underneath the radical is called the radicand. Now, if there's a number in front of the radical symbol that's above here, not out in front, but above here in front of it, that's going to be a root. So depending on what number is there, that's going to be the root it's going to be. So 3 in this case is it's going to be the third root. So we're going to take the cubed root of it. And so any value of n we can plug in here. And so if we have n is equal to 2, that's just the square root. Then we have 3, that'd be cubed root. Then a fourth would be the fourth root, fifth root, and so on. And so the nth root of a is equal to b if and only if a is equal to b to the n. And so that kind of comes back here. If n is 2, when we take the square root of that, we just get square root of a. And we get b on this side. So if we take the nth root of b to the n, we're going to get b over here and the nth root of a over here. So if n is even, then a and b must be greater than or equal to 0. So we can't have a negative number. But if n is odd, then a and b can be any real number. So it can be positive or negative. So when we have even values of n, or just a square root, so 2, 4, 6, 8, then we have to have a positive number for a and b. But if we have odd ones, 3, 5, 7, then we can have either a positive or a negative value. So these are some examples of square roots. These are, perfect squares basically. And so the square root of 1, well, that's 1. The square root of 4, which is 2 squared, that's going to be equal to 2. Now the square root of 9, which is 3 squared, is equal to 3. Because here again, we're taking the square root of a is equal to b if and only if a is equal to that squared. So, 3 squared is 9, and so that's how we get the square root here. Now, when a square root of 121, now that's 11 times 11, so that's 11. And square root of 441, now we're getting bigger numbers, and so most likely you're going to have a calculator unless you remember those, and that would be 21. Now here is an example when it doesn't work, the square root of negative 49. Well, that's not a real number because we've said if it's even, it has to be greater than or equal to 0. Well, negative 49 is not equal to or greater than 0, and so therefore it's not a real number, and later we'll find out that's going to be an imaginary number actually. All right, so for the simplification of radicals, foremost what we need to do is be exact as possible in using radicals. So if we're taking a root and it doesn't come out as a whole number, like the square root of 4 is 2, then what we want to do is we want to keep it as a radical. Don't use the calculator, find out it's 7.89572333348. Don't do that, because at some point you're rounding, because your calculator is only going to show you so many of those decimal places, and so we're going to keep it as a radical. All right, so that's the key thing when we're doing these. Now we can have a couple of rules. So the first one is the product rule for radicals. So if a and b are two positive real numbers, then we can say, okay, well, the square root of a times b is equal to the square root of a times the square root of b. So we can split this apart into the square root of a times the square root of b. Or what we could do is also go from this side. We can say, well, the square root of a times the square root of b is equal to the square root of a times b and underneath the radical. Now in general, if a and b are two positive real numbers, then the nth root of a b, or a times b, is equal to the nth root of a times nth root of b. And again, this is for n as positive integers and greater than or equal to 2. So, we have the second, which is just a plain old square root, and then we have 3, then 4, then 5. And again, a and b have to be positive real numbers whenever you have n is an even number. We also have the rational exponents and radicals kind of rule. And so it says let a be the base and m and n be real numbers. Then a, which is our base, raised to the power m over n, that's equal to the nth root of a to the m. Okay, because our denominator is going to give us our root, and our numerator is going to give us our exponent that we raise our base to. And so we're taking a to the m power but we're taking the nth root of that a raised to the n power. And we can also write it as this way. We can say it's nth root of a, the whole thing raised to the n power. So you can have it underneath here, or we can have it out here, okay? Now the denominator of rational exponent is the root on the radical and vice versa. So like kind of what I was saying, that's our root, and so it goes here. Now simplifying these, we can convert the base to a rational exponent and reduce the fraction to lowest terms. Well, we know that the square root is a 2 here, so that's going to be a fraction over 2, so n is going to be 2, so we know it's y to the 8th, so we say, oh, that's 2, and that becomes 8 over 2, kind of like what we have here, and then 8 over 2 is 4, and so our final value is just y to the 4th. Okay, and that starts out with what is the square root of y to the 8th. So we can simplify those radicals by reducing the fraction. And so, if this had been the cubed root of, say, y to the 9th, then, we'd have something, if we can write it here, cubed root of y to the 9th, well, that's going to be y to the 9 over 3, which is y to the 3rd. So it works with odd or even. You just divide them out, and hopefully you're going to get that the whole number for an exponent, and that's what we are going to look for. Now, simplifying radicals with variables, here we just use the product rule to separate the variables and then rewrite rational exponents, reducing them to the simplest terms. And we'll see that when we actually start working with these with radicals with the variables. So let's start going through these, and we're just going to simplify the radicals. So that's the key thing here is for a few, 10 problems or so, we're going to simplify radicals. Well, here they say, what is the square root of 36? Well, we can break that down as that's the square root of 6 squared, because 6 times 6 is 36, and the square root of that is just going to be 6. Now here, this one we can break out, and this is going to be equal to 3 times the square root. Well, 12 we can break into 4 times 3. Now that gives us 3 times the square root of 4 times the square root of 3. So we're just kind of breaking this down. And the square root of 4 is 2. So that becomes 2. And so we have 3 times 2 is 6. And we still have our radical 3. Okay, so we basically had to take the 12, break it down into the two pieces, 4 times 3, and one of them we have to try to make a perfect square, and then when we take the square root of that perfect square, we just get 2, and then we just take that 2 times the number out in front, which is 3, which is 6, and then keep our radical 3. All right, so this one, we kind of have to work our way through and think about what these are. So we have a negative 8 out in front, and 392. Now a lot of these, the key to working these is just, take and divide them out. And so if we see this is going to be times 2, or we can divide by 2, and if we divide that, that's going to be 196. And 196, that's going to be a perfect square, because what we have is 14 times 14, I can write that nicely, that's equal to 196. And so then we have negative 8 times the square root of 2 times the square root of 196. And so that's a negative 8 times the square root of 2 times, well, the square root of 96 is going to be 14. And now what we can do is take the 8 times our 14, and that should give us a negative 1, 2, then the square root of 2. Okay, and so that would then be our final value. So we had to break that radicand up underneath the radical sign and into 2 times 196, and then we could put 2 of them, and we know that's equal to 14. So then we have 14 times 8, and then times the radical 2. All right, well, 196 we just said was 14 when we take the square root of it. And so this is one with a variable. And so we're going to have the square root of 196 times the square root of v squared. Now, if we want to, we could rewrite this as, the square root of 14 squared times the square root of v squared. And then if we wanted to use the power and make them fractions, that's equal to the 14 at 2 over 2 times v, and it's again 2 over 2. Well, 2 over 2 is just 1, so that's just going to give us 14v. And that's the same thing here. You know, square root of something squared is just going to give us whatever the variable is, in this case v, and so we get the 14v as our final answer. So we broke down our numerical part as well as our variable part. All right, so this one here, we have, again, a numerical part and a variable part. And so we can have, okay, well, that's going to be a negative. Now we can split these apart. The square root of 100 times the square root of k to the fourth. Okay. Now again, well, square root of 100, well, that's going to be 10 squared, so that's just going to be minus, and then we have a 10, because that's 10 squared. Now this one, if we need to, we can say, well, that's k to the 4 over 2, because we take our power over the number out front, and for the square root, it's just a 2, and that equals k squared, and so this is negative 10k squared. That would be our final answer. Okay, so this one here, what we have is we see the same kind of thing. So we have a negative 5 out front, then we'll have the square root of 36 times the square root of m. Well, the square root of 36 was our first problem. That was just 6. So we have 6 times a negative 5, so that's a negative 30. Well, this is m, and that's to the 1 power, so 1 over 2 is a half. Well, that's still just a square root of m. We can't reduce it, and we want it to be in the most exact form, so we'll just leave it as negative 30 times the square root of m. All right, so this one we have a little bit different thing. Now what we're going to do is we have to reduce again. Well, if we break this apart, that's the square root of 16 times the square root of x to the third times the square root of y to the third. Okay, well, the square root of 16 is what? Well, that's 4 times 4, so we have 4. Now this one, we can look at x cubed. Well, that's really just x squared times x. And the reason why I break this apart like that, because I know x squared, the square root of that is just x. And so I can break this into the square root of x squared times the square root of x. And then that will make that piece simplify. And then y cubed, I can do the same thing. That's going to give me a square root of y squared times the square root of y. And now this is equal to x. This is equal to y. So we have 4xy square root of, I still have square root of x times the square root of y. And remember, I can put those two together underneath one radical again. And so I have 4xy square root of xy. And so that's what the square root of 16x cubed y cubed is. And so I just kind of had to look at each piece and go from there. Now again, now x to the 3 over 2, we could have done that. Well, that's going to be, well, that's 1.5. So we can have, well, that's x to the 1 times x to the 1/2. And so then the x to the 1/2, that's the same thing as square root of x. And then we just have that x here, and so that's that x there. So it kind of depends on how you want to look at it. When I split it apart, I looked at it as where I could take the square root and make it divide evenly, and then whatever was left over, because x is the same thing, and remember, as x to the 1. All right, here what do we have? Well, we have 60 times the square root of 80 times the square root of x times the square root of y squared. Okay. What do we have here? The square root of x is just going to stay that, but the square root of y squared, that's just going to be y. So I can bring it out front. So I have 6 times y. Now about the square root of 80. Well, that's going to be, if we think about that, what do we have here? That's going to be 5 will go in there, and 5 will go in there 1, 6. That should give us that. And so that's going to be the square root of 5 times the square root of 16. This one we know is just equal to 4. So that's going to be times of 4, and then times the square root of 5. And then we still have our square root of x. So we kind of are just splitting it all apart as much as possible. And then our next line, we're going to put it all back together. So 6 times 4, well, that's 24. We still have y. Square root of 5 times the square root of x. That's the square root of 5x, because we can put them back together again. Okay. Let's look at a couple more here. All right, so here we have a negative 2, then we have a square root of 180, the square root of u cubed, and the square root of v. Now that's u cubed. We can rewrite that as that u squared times u to the first, and then we take the square root of u squared square root of u, and then we have u square root of u, because that one is a perfect square, so it becomes u. Now 180 and breaking it down, let's see, 180, if we divide that by 5, that'll give us a square root of 5. And then that will go in there 3, and then it'll be, it looks like 6. And so the square root of 36 we know is 6. So that's 6 square root of 5. Okay. So this we have -2 times 6 square root of 5 times, now u cubed we said was u square root of u, and the square root of v is still the square root of v. Now we can multiply across. So 2 times 6 is 12, so it's going to be a -12. We have a u also out here. And then under the square roots, we have 5 times u times v. So we'll have 5uv. Okay. And so that should be this number here broken down as much as possible. -12u square root of 5uv. Okay. All right, so let's go back to the next one, and we're back to 80. Now remember 80 over here, we did that one already, and that was basically 5 times 4, the square root of 5 times 4. So we know we can get that one pretty simple. So that's 2 square root of 80 times the square root of h times the square root of j to the 4 times the square root of k. Well, the square root of 80, we said that was going to be square root of 5 times the square root of 16, I believe. Yep. So that's going to be 2 times 4 times the square root of 5. All right, so now the square root of h, we can't simplify that, so it's there. Now j to the 4th, well, j to the 4 over 2 is what this says. J to the 4 over 2, well, that's just a j, not a y, j squared. And so this becomes j squared, and then we still have the square root of k. So now we multiply everything back together, so we have 2 times 4 is 8. Then we have a j squared outside. And then we have the square root of everything here, 5hk. Okay. And so that's going to be our final solution. And again, breaking down each individual piece, and then once we get them all simplified, we can put everything back together, multiply as needed, and we have our final solution. All right, so now what we have is we've been looking at, radicals, and now what we're going to take is we're going to have an expression we want to write that in the radical like that, or we could have said the square root of 7x and then the whole thing raised to power 3. Okay, and so that's going to be the key here, however you want to look at it. And so both of those would be correct. It doesn't say to expand it, and so we don't really have to expand it. If we take and multiply 7 times 7, that's 49, times 7 again, that's equal to 343, and then we take x and cube it, and so that would be the totally expanded out form of both of those. Okay. What about this one? Here, what we have is we have a negative exponent. Now, what do we know about negative exponents? Well, we can make them positive by taking it to the other side. So if it's in a denominator, we take it in the numerator. If it's in a numerator, as the case is here, we take it to the denominator. And so that becomes 1 over 10r to the positive 3 over 4. Okay. So we know our root is 4, and so that's going to give us 1 over the 4th root of. Now we have the whole thing, 10r is under that, and then where'd r go? R. And then what we can do is we can cube what's inside here and say, okay, well, that's 10r cubed, or we can say that's 1 over the 4th root of 10r, and then a cubed here. Okay, so it depends on if you want to put it on the inside or the outside. If we put it here, we could even write it as the 4th root of 10 cubed is going to be 1,000, and then it's r to the 3rd. Okay. All right, so here we're supposed to write the expression in exponential form, okay? So now we're going the opposite way. And so what do we have with this one? Well, we can write this as 1 over, now it's the 4th root, so it's going to be n, and the n is raised to the 7th power, so it's going to be 7 over the 4, okay? Now, I'm assuming they want everything in the numerator, and like we had over here, we had one with a negative, and we had to go to the denominator. So now let's take that up to the numerator, and so that's going to give us n to the negative 7 over 4. Because we've taken it to the numerator, we've changed it to a negative, and that would be the expression in the simplest exponential form, no fractions. Okay. Well, what does this one say? Well, it's saying take the square root of 5a. So what that means is we're going to take 5a and we're going to raise it to the 1/2 because our n here is 2. It's a assumed 2, and you don't have anything. It's 2, and this is all to the 1 power, so it's 1 over 2. So it's 5a to the 1/2. Okay. All right, so now we're supposed to evaluate these without a calculator. Now, I can't ever see what you're doing probably, so you could use the calculator and I'd never know, but what we're going to do is we're going to show you how we would do that. And so how we're going to do that is we're going to look at this and say, well, this is the nth root, so that's a cubed root of 8, and then that is going to be squared, okay? Well, what is 8? Well, if you remember, 8 is 2 times 2 times 2, which is 2 cubed. So this is really 2 cubed over 3. Well, 2 cubed over 3 over 3, that's just 2 to the 1st. So that's just equal to 2 squared, because we have our squared here, and that gives us 4. Okay, so we had to simplify this cubed root of 8, and we had to think of that as, 2 cubed, which is what 8 is, to the 1 over 3 power, so then it's 3 over 3, and that's just equal to 2, and then we raise that to that power 2, and we'll get our 4. Same thing will work here. So I'm going to say, okay, well, I'm taking the square root, because 2 is going to mean square root. I'm going to take the square root of 4, and then I'm going to raise that whole thing to the 3rd power. Okay, well, what's the square root of 4? Well, the square root of 4 is 2, and I'm raising that to the 3rd power, and I've already said up here, well, 2 cubed is 8, and so this is equal to 8. All right, what about this one? Here we're just saying we want to take the 4th root of 16. Well, what is 16? Well, 16 is 2 times 2 times 2, which is our 8, times one more 2, so that's 2 to the 4th. And so really this is 2 to the 4, and we want to take that to the 4th root, so it's over 4, so that just gives us 2, because 4 divided by 4 is 1, which gives us our 2 here. All right, what about this one? Well, here we have to kind of look at this as, okay, well, that's going to put it over something if we want to make it positive. So that's going to be 1 over, and then we're going to have the square root of 100, and then we're going to take that and cube it. Okay, so it's 100 to the 3 over 2, and it's on the bottom. We was up here with the negative, but we made it down here to the positive, and so now we have 1 over, well, the square root of 100 is 10, and we're still going to cube that, and so that cubed is 1 over 1,000. We just make it 3 zeros, and that's going to be our value. Okay. All right, so that's all I have for this section.